Okay, so hi. So for this video, we will be discussing the second property of Laplace transforms, which is called the first shifting property. So for the first shifting property, so if we have a given that the Laplace transform of f of t is f of s, when s is greater than a, then the Laplace transform of e raised to at multiplied by f of t is equal to f of s minus a. So this means that if our function, okay, our f of t has a multiplier of e raised to at, then the s, okay, so all the s of the Laplace transform of f of t will be replaced by s minus a. Okay, so and then from there, so we will just simplify. So say for example, so we have the Laplace transform of e raised to negative 3t times cosine of 5t. Okay, so in this form, so as you can see, our f of t is cosine 5t, and then e raised to negative 3t, that is e raised to 8t. Okay, so obviously our a is equal to negative 3. Okay, so our f of t is cosine of 5t. So therefore, so since the Laplace transform of cosine of 5t is equal to, so formula, so recall the Laplace transform of cosine omega t is equal to s over s squared plus omega squared. So our omega here is 5. So therefore, our Laplace transform is s over s squared plus 5 squared. Okay, so since that is the Laplace transform of cosine of 5t, so that is our f of s. Therefore, if we have a multiplier of e raised to negative 3t, therefore all the s will be replaced by s minus negative 3. Okay, so therefore the Laplace transform of e raised to the negative 3t cosine 5t is equal to, so replace s with s minus a. Okay, so s minus negative 3, okay, for here, and then the s here be replaced by s minus negative 3 squared plus 5 squared. Okay, so all we did was replace s with s minus negative 3, okay, or s minus a. So simplifying that, so that will become, the numerator will become s plus 3, the denominator will become s plus 3 squared, so that is s squared plus 6s plus 9 plus 25. Okay, so simplifying, so the Laplace transform is now equal to s plus 3 over s squared plus 6s plus 25 plus 9, that is 34. So that is now the Laplace transform of e raised to the negative 3t cosine of 5t. Okay, so another example, so we have the Laplace transform of 4 t cubed e to the negative t. So we can take out the numerical coefficient, the constant coefficient. So we have 4 Laplace transform of, we can rearrange this, so e to the negative t times t cubed. Okay, so our f of t here is t cubed. Okay, and its Laplace transform, so the Laplace transform of t cubed is equal to 3 factorial over s raised to 3 plus 1. Okay, so remember the formula, the Laplace transform of t raised to n is equal to n factorial over s raised to n plus 1. Okay, so the Laplace transform of that will be 3 factorial that is 3 times 2 times 1. So that is 6 over s to the power of 4. Okay, so since this is the Laplace transform of t cubed, so now if we have a multiplier of e raised to the negative t, okay, so we need to replace all the s with s minus negative 1. Okay, so because our a here is negative 1, so therefore that will become 4 times Laplace transform now will become 6 over s to the 4th, but s replace it with s minus negative 1. So 6 over s minus negative 1, so that will become s plus 1 raised to the power of 4. So therefore, the Laplace transform of 4 t cubed e to the negative t is equal to, we have 4 times 6, so we have 24 over s plus 1 raised to the power of 4. Okay, so it's that simple. Okay, so all we need to do is get the Laplace transform of f of t and then replace s with s minus a. Okay, so for our final example, so find the Laplace transform of 2t squared e to the negative t minus sine squared of t. Okay, so for the first term of the Laplace transform, so obviously we will be using this first shifting property. For the second, so since it has no multiplier, okay, of e to the negative t, then we will just take the Laplace transform of this using the ordinary way. Okay, so but unfortunately we don't have the Laplace transform of sine squared of t. Okay, but what we can do is that we can use the trigonometric identities, okay, to express sine squared of t in terms of functions that has formulas for Laplace transform. Okay, so particularly here we can use the double angle identity of cosine. Okay, so recall that sine squared of x is equal to 1/2 times 1 minus cosine of 2x. Okay, so therefore we can apply that here. So applying first the linearity property, so we have Laplace transform of 2t squared e to the negative t minus Laplace transform of sine squared of t. Okay, and then next is taking out the constant, so we'll have 2 Laplace transform of rearranging this, so we'll have e to the negative t times t squared minus Laplace transform of, so we can replace this with this, so we have 1/2 times 1 minus cosine 2x okay, and then this will become, let's copy this and then let's distribute 1/2 and the Laplace transform, so this will become 2 copy Laplace transform of e to the negative t times t squared minus 1/2 Laplace transform of 1 and then negative, so we'll have plus still 1/2 Laplace transform of cosine of 2x. Okay, so now we can get the Laplace transform of each. So Laplace transform of t squared is 2 factorial over s raised to 2 plus 1. Okay, but we have here the first shifting property, so therefore we will replace s with s minus negative 1, okay, or s plus 1. So this will become 2 times the Laplace transform of t squared is 2 factorial, okay, over s raised to 2 plus 1. Okay, but since we have here a multiplier of e raised to the negative t, therefore we will be following the first shifting property, where our s will be replaced by s minus negative 1 or s plus 1. So over s plus 1 raised to 2 plus 1. Okay, minus 1 half. Laplace transform of 1 is 1 over s, and then plus 1 half. Laplace transform of cosine 2x is s over s squared plus 2 squared. Okay, so simplifying this, so this will become 2 times 2 factorial, so that is 4. So we will have 4 over s plus 1 cube minus 1 half times 1 over s, so that will become 1 over 2s plus, we have 1 times s is s, 2 times s squared plus 2 squared, so that is 2 times s squared plus 4. Okay, so this is now our Laplace transform. So if you want to combine it into a similar term, so it's okay, but this is already a sufficient form of the final answer. Okay, so that's it.